Welcome to the DIY Honda Garage channel. The DTC P068A indicates an issue with the PCM, or Powertrain Control Module power source circuit, that is experiencing unexpected voltage behavior. This code relates to the PGM-FI system, which stands for Programmed Fuel Injection, an integral part of the engine management functionality. The PCM is responsible for various critical tasks including fuel delivery, ignition timing, and emissions control. It is generally located in the engine compartment, often secured to the vehicle's chassis. When this specific DTC is flagged, it suggests there might be faulty electrical connections affecting the relay circuit board, which distributes power to the PCM. It is crucial to address this issue promptly, as it can lead to engine performance problems and inefficient fuel usage. DTC P068A points to an unexpected voltage in the PCM power source circuit, which involves two critical components: the Powertrain Control Module, PCM, and the relay circuit board. The PCM is the vehicle's management brain, handling functions like fuel injection and ignition timing. Any voltage aberrations can disrupt its ability to function correctly, affecting overall performance and emissions. The relay circuit board plays a vital role by providing consistent power to the PCM and is typically located within the underhood fuse/relay box. If this board has faults, the PCM won't receive the necessary power, leading to this DTC. Therefore, both components should be closely examined during troubleshooting to identify the cause of the voltage inconsistency. Several factors could lead to the appearance of DTC P06A. One possible issue is poor connections, which can hinder electrical pathways and disrupt voltage supply to the PCM. Loose terminals at the relay circuit board or PCM are often the culprit and should be checked first. A faulty relay circuit board itself might not pass the necessary voltage to the PCM, triggering this code. Additionally, a blown fuse, specifically number A7, located within the underhood fuse relay box, can cause power failure to components reliant on it. Each of these potential causes should be systematically evaluated during the troubleshooting process to ensure a complete resolution. Identifying the symptoms associated with DTC P068A can provide insights into the potential severity and specifics of the malfunction. Drivers may experience engine performance issues, which can manifest as reduced power, poor acceleration, or erratic running. Intermittent starting problems are also a common symptom, as the PCM may not always receive the required voltage to initiate engine functions. Furthermore, malfunctioning fuel injection can occur, leading to poor combustion and increased emissions. Additionally, a general PCM malfunction could present itself through other DTCs, indicating that diagnosis and repair of the P068A code is crucial for restoring adequate vehicle performance. The first step in troubleshooting DTC P06AA requires verifying the authenticity of the code. Begin by turning the vehicle to the on mode without starting the engine. This activates the vehicle systems and prepares the onboard diagnostic tools for operation. Next, utilize the HDS or Honda Diagnostics system to clear any existing DTCs. Afterward, turn the vehicle to the off or lock mode to reset the system. Finally, turn the vehicle back to the on mode to check if the DTC returns. If this particular DTC emerges again, it indicates a confirmed failure and prompts the technician to move on to the subsequent investigative steps. In this troubleshooting step, the emphasis is on the relay circuit board. The technician should begin by ensuring the vehicle is in the off mode for safety and to prevent any potential electrical mishaps. Proceed to remove the relay circuit board carefully and conduct a thorough testing procedure. This board controls power distribution to the PCM, so any faults here could directly relate to the DTC being investigated. Once the board is removed, test it for continuity and functionality using appropriate tools. If the relay circuit board is found to be faulty, it should be replaced immediately. Moving on to the next troubleshooting step if it's in good working condition. Now we shift the focus to the fuse responsible for powering the PCM and relay circuits. Check fuse number A7, rated at 20 amps, which is located within the underhood fuse relay box. The role of this fuse is critical as it safeguards the electrical circuit from overload and potential damage. A blown fuse could easily lead to the DTC P068A being triggered, indicating that the PCM is not receiving the necessary voltage. Inspect the fuse visually for any signs of damage, or use a multimeter to check for continuity. Should the fuse be intact, you will proceed to the next troubleshooting step. Conversely, if it is blown, replacing it should be your immediate action. The fourth troubleshooting step involves checking for shorted wires in the system. Begin by removing the blown fuse number A7 from the underhood fuse/relay box to prevent further electrical issues. With the fuse removed, check for continuity between two specific test points. Test point 1 being the relay circuit board connector terminal number 18, and test point 2 being a solid body ground. This check should only be conducted with the vehicle in off or lock mode, and the relay circuit board removed to ensure accurate results. If you find continuity, it indicates that there is a short in the +B IGP line running between the relay circuit board and the fuse, requiring immediate repairs. If there is no continuity, the troubleshooting will proceed to the next step. This step focuses on diagnosing the FI main RLI outline for potential short-circuiting issues. Start by removing the PGM-FI main relay 2, which is essential for power distribution to the PCM. Next, jump the SCS line or SRS communication line with the HDS to test the system more effectively. After waiting for a minute for the circuits to stabilize, disconnect PCM connector number 2. Continuity checks should be made between specific test points: the relay circuit board connector terminal number 17 and body ground, with the vehicle still in off mode. If continuity is detected, it indicates a fault in the FI main RLI outwire that requires repair. Should there be no continuity, further checks on service information may be necessary. In this sixth step, focus on the +B IGP line to check for open wiring issues. Measure the voltage between two designated test points in the vehicle while keeping it in off mode. Test point 1 is at the relay circuit board connector terminal number 18, and test point 2 is to a solid body ground. This measurement should confirm whether battery voltage is present at the specified test points. A positive reading indicates that the line is intact, leading you to the subsequent troubleshooting step. Conversely, if no battery voltage is detected, this suggests there is an open circuit in the +B IGP wire, necessitating repairs to rectify the problem. Step 7 revolves around diagnosing the FI main railie clear line. Begin by jumping the SCS line again using the HDS tool, allowing the system to stabilize for a minute. Disconnect the PCM connector number 2 to prepare for the continuity check. Like previous steps, verify continuity between designated test points, the relay circuit board connector terminal number 5 and PCM connector number 2, terminal number 26, ensuring the vehicle is still off. If continuity is present, it indicates that the FI main railie clear wire is intact. However, any lack of continuity signals an open in the wire that requires repair, specifically between the relay circuit board and the PCM. In the final troubleshooting step, the focus shifts to verifying the integrity of the FI main rally outline. Once again, keep the vehicle in off or lock mode, while checking for continuity between the relevant test points, the relay circuit board connector terminal number 17, and multiple terminals at PCM connector number 2, specifically number 2, number 4, and number 6. If continuity is confirmed, it suggests the wiring is intact, allowing you to shift focus towards any authorized service information related to the DTCs or symptoms that you need to troubleshoot further. If continuity is not present, it signifies potential wiring issues within the FI main relay outline that require immediate attention and repair. After completing all the troubleshooting steps related to DTC P068A, it is vital to perform a final repair verification. Begin this process by checking if there are any remaining or confirmed DTCs, ensuring that the previous faults have been addressed effectively. Following this, test the vehicle's performance under various conditions to guarantee that any issues previously encountered have been resolved. It's also essential to ensure that all electrical connections are secure and operational, mitigating the risk of recurrence for the problem. Remember that a thorough verification not only confirms repairs, but also enhances overall vehicle reliability and functionality. Preventive maintenance is crucial in ensuring the longevity and reliability of automotive electrical systems, particularly with regard to DTC P068A. A routine inspection of electrical connections can help identify potential issues before they escalate into significant problems. Regularly checking the status of fuses, especially those related to critical components like the PCM, can preempt any electrical failures. Additionally, monitoring voltage readings in key circuits routinely allows you to catch abnormalities early. Implementing these preventive measures not only saves you time and money on repairs, but also enhances the vehicle's overall health. In conclusion, DTC P068A signals a critical voltage issue within the PCM power source circuit that should be addressed without delay. A systematic approach to troubleshooting, as outlined above, ensures that all potential causes are evaluated effectively, from relay malfunctions to open wiring. Key components, such as the relay circuit board and associated fuses, play crucial roles in the functioning of the PCM, and identifying faults in these areas is vital. Furthermore, consistent preventive maintenance practices will help ensure that your Honda Civic operates smoothly while avoiding costly repairs. Being proactive in vehicle care is essential for both performance and reliability. Please like and subscribe to the channel. See you next time.